In this problem, we are given an array and a target value. Our task is that if we add any two numbers in this array, we need to get the target. Okay, so what we have to return is we need to return the indexes, not the values itself. So how can we approach this? Here is our array. What we can do is we can keep a pointer at a value, then we can go to the next value, add this both values, then compare it with the target whether it is equal or not. The same thing we can repeat it again. So we are moving the pointer, then adding the value and comparing it whether it is equal to the target or not. Again we are moving the pointer and adding the values and checking whether it is equal to the target or not. So when we reach the end of this array, we can move the pointer and place it here. Then we can check whether this value is added with this value gives the target, and check this both values. Then after reaching the end of the array, we can move this pointer, then check whether it is equal. So we came to that end, right? So we can stop the pointer within this index itself. This is our brute force code. So we have used two for loops here. One pointer is placed at one index, the other pointer will be traversing throughout the array, and we will be adding and comparing at the same time. Okay, so yeah, this is our array. So first pointer is at 0th index and the next pointer is at first index. So we will be adding these two and we will be checking whether it is equal to the target or not. Here it is equal to the target. So within the first loop result we are getting the output. We'll be adding both the values and compare it with the target, and this condition is true. So this if loop will be executed. So what we are returning is we are creating an integer array. Okay, so we are creating an integer array and assigning the values of this both indexes of this value. Okay, so it will return the indexes of the values as the output. We can see one more example here. So this is our array. We have the target. So during the first loop, the first pointer does 0th position and the second is at the jth position. So it will add and compare with the target. It is not equal to the target. Since this is not equal to the target, the j pointer moves to the next index. Okay, so the j pointer is incremented to the next index, that is 2. So now I is in the first position and j is in the second position. So this 2 will be added and compared with the target. So this is also not equal, so j pointer will move to the next index. So we will be adding this both and checking whether it is equal to the target or not. No, again it is not equal to the target, but j came to the end of the array, right? So here we have, so what is now j value is 4. 4 less than the length of the array is also 4. So 4 less than 4, the condition is false, right? So 4 less than 4 is false. So this for loop it loops ends here. Then the this for loop is incremented. So I value is incremented to 1. Already we have 0. Now it is incremented to 1. So we have I value 1. Then j value I plus 1. So 1 plus 1, that is 2. So we have I pointer in first index and j pointer in second index. So we will be adding these two, checking with the target, again not equal. Then moving the j pointer, we will be checking whether it is adding and checking whether it is equal. No, it is not equal. Then so the j pointer came to the end of the array, and during the next increment it goes to 4. So again 4 less than 4 is not equal, so this for loop j loop is just entered. Then the ith loop is incremented. So the value of I is 2 now. Value of I is 2, then j will be at 3. So we will add this both and compare it with the target. Yeah, we got our values, right? So this is our brute force. It takes big O of n square times complexity because we are using 2 loops. So the array traverses up to the n values. So we can have an optimal solution using HashMap. So this is the Java data structure. So what is the HashMap? HashMap takes values in key values files. Okay, so it uses key and the value. Key is always unique. We can't have duplicate values in key, but the value can be duplicate or unique. Okay, but keys cannot be duplicate. Using this key value, we can access this value. Using this key, we will be accessing this value. So this is how our HashMap value is stored. Now what we are doing here is we are just creating an empty HashMap here. So we will be creating an empty HashMap here. In the brute force solution, we added 2 elements at a time, then check whether this is equal to the target or not, right? But in this solution, we will be subtracting each integer value, each index from the target. We will be subtracting each values from the target and check whether that value is in the map or not. If it is in the map, then that value in the map and the index value forms the target. Okay. Here we have our array and we have initialized the empty HashMap here. So what we will do is we will traverse through this array. We will browse through this array. Then we will add each element in the array in the HashMap. Then we will be checking whether if we add this, whether we subtract this with the target, we have the value in this HashMap or not. Okay. So we can put the first value. So we can start with the index 0. So we can then we are subtracting the index 0 with the target. So from the target we subtract the index 0 value, that is 1, and check whether the value is in this map or not. It is not, right? Currently our map is empty. So what we will do is we will add this first element to this map. So we are adding the element as key and its index as the value. Okay, because we need to return the index, right? We don't want to return the value. So what we will be doing is we will be placing the index in the value. Then the I pointer is increased and goes to the next element. So we have 3, right? So this is 3 is subtracted from the target and we get out that 3. Now we will be checking whether it is in the map or not. It is not in the map. So what we will put this 3 inside this HashMap and along with its index value 1. Then the next value is 2. I pointer is implemented and the next value is 2. So we will be subtracting the 2 from our target. Subtracting 2 from our target, then value is 4. It will check whether it is in the map or not. No, it is not in the map. So what we will do, we will be putting the 2 in the HashMap as a key and its index 2 as a value. Okay. So now I pointer is implemented. Now it is going to the index 3. Now we are checking whether there is value 4. Value 4. Okay. So we are subtracting the target value from this 4 and we have twice the output. Now we are checking whether this is in the map or not. Yes, it is in the map, right? So it is in the map. So what we will be doing is we will be getting its value. We will be getting its value. Okay. So using this getDraw function, we can get the value of the key. Okay. So what the sign does, it will be checking whether it is contains in the key or not. So map.contains will check whether the value is in the key or not. So if it is in the key, what it does, it will create an array. It will get the value from the map. Okay, corresponding to that key. which value is there, it will be getting that value. Then also the current array value, that is I. So the value in the index I. So these two forms the target. Okay. So these two will be written. So the entire code is, so we'll be creating a hash map, empty hash map. Then we will be looping through all the elements in the array. So we will be subtracting each element from the target and storing it into the value. We will be checking whether this value is inside the map or not. Okay. So this currently check whether it is in the map or not. So if it is not, we will be putting that value inside the map. So this is the function will put the value in the map. It holds two values. One is C and the other is the value. So we are using the value. We are using the value as C and index as its value. HashMap value. Okay.